Welcome to another installment of geometry. This part of the unit we'll be discussing today are congruent triangles. My common sense tells me that a confluence of congruence brings out the parlance of flatulence that accompanies ignorance. That's my rap career right there. Okay, if two geometric figures have exactly the same shape and size, they are congruent. So, congruent figures, if you look here, we could take any one of these figures and spin it and put it on another figure, and it would be the same exact size and same exact shape. Okay, we can see these all look very similar, these shapes, but they're not the same exact size, nor are they the same exact shape. Okay, so the definition of congruent polygons. So two polygons are congruent if and only if their corresponding parts are congruent. So we have here in these two triangles are congruent. They're the same exact size, same exact shape. So their corresponding angles are congruent. If you look at angle A and angle H, both of those have the same markings. Angle B and angle J have the same markings, and angle C and angle K have the same exact markings. Their corresponding sides also have the same markings. Segment AB is congruent to segment HJ. Segment BC is congruent to segment JK. Segment AC is congruent to segment HK. So our congruent statement, you have to match up each of these angles with the proper corresponding angle. A is congruent to H, so they must be in the same order. So triangle ABC is congruent to triangle HJK. Each one of those angles must match up in order. What if you have a different order? What if I said triangle CBA? Well, then you would say triangle KJH. All right, it doesn't matter the order. It only matters that the corresponding angles or vertices match up. Okay, the third angle theorem, and what this says is if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So if angle C is congruent to angle K and angle B is congruent to angle J, then angle A is congruent to angle H. And the reason we know this is, well, because all angles of a triangle have to add up to 180. So if we subtract equal things out from each side, then what ends up happening is the last pair of angles have to be the same amount. Okay? So if we were to do a proof of this, we would know that angle A plus angle B plus angle C equals 180. And we also know then that angle, we'll say that angle H plus angle J plus angle K would also equal 180. Well, if this is equal to this, then the left sides are equal also. So we could end up saying here is that angle A plus angle B plus angle C is equal to angle H plus angle J plus angle K. Now, we can subtract out things that are equal from each side. So if we have here, I know that angle C is congruent to angle K, so I'm going to subtract those out, right? We'll just go ahead and do it this way. So I'm just going to say angle C is congruent to angle K, and angle B is equal to angle J. Well, then what ends up remaining is the final piece, which is angle A is equal to angle H. Okay? Well, we've done this whole big proof of this, and because of that, we've got our third angle theorem proven.
Cowabunga, dude!
All right. So properties of triangle congruence. The reflexive property says a triangle is congruent to itself. That makes sense, right? The symmetric property of triangle congruence says, well, if triangle ABC is congruent to triangle EFG, then triangle EFG is congruent to triangle ABC. The order doesn't matter. That's symmetry, right? If A equals B, then B equals A. Same concept, symmetry. The transitive property is if I have two triangles right here, I say that triangle ABC, this one here, is congruent to this one. And EFJ is now congruent to this one. Well, then these two are now congruent. Okay, so in the diagram, triangle ABC is congruent to triangle DFE. Find the values of X and Y. Well, in this first part here, so we've got to do a little thinking before we begin our quest to solve this. I can solve for Y by making angle F, right? So angle F is, if we look at the names here, angle B matches up to angle F. So we're going to mark these two angles congruent, right? Now, this one has two variables, so I have to solve for Y first, right? So segment FE, right, that's these two together, that matches up with BC. So this here matches up to this one here. Okay, so we've marked this, now we can solve it. So I'm going to say that 8y minus 5 equals 99. So now we're just going to take this concept and do some algebra. So we're going to add 5 to each side here. And I've got 8y is equal to 99 plus 5 is 104. So now we just use our handy dandy calculator and we divide each side by 8. And y is equal to 104 divided by 8, and that comes out to 13. So y is equal to 13. Now, I've got 2y plus x equals 38.4. Well, I know y is equal to 13, so I'm going to take y out, and I'm going to put 13 in. Now I'm going to multiply this. I got 26 plus x equals 38.4. So we subtract 26 from each side, right? So I'll write that in here, minus subtract 26. And I get x is equal to 12.4. All right, so there's our x and y values. Okay, and this problem here in the diagram, triangle RSV is congruent to triangle TVS. Find the values of x and y. All right, so we want to match things up. So what helps to do a lot of times is to copy the diagram down and draw it the best you can. But I know triangle, so angle R goes to angle T, right? Angle S, which is this 90-degree angle, matches up to angle V in this triangle. So this is going to be a right angle here. Angle V in this triangle matches up to this one here. So this one here is also 78 degrees. This is a tricky problem. Okay, so I want to solve for x. Well, I've already marked this up that this is 90 and 78. So x plus 90 plus 78 equals 180, right? So x plus 168 equals 180. If I subtract 168 from each side of this equation, I end up with x is equal to 12. Now, let's take a look at segment RS. So segment RS, which is this one right here, right? So that's these two here. Well, that's got to match up to segment TV, right? In this triangle. So we're going to match up with this one right here. So we're going to go ahead and set up our equation now. 2y minus 1 equals 24. So I'm going to add 1 to each side. I get 2y equals 25. Divide each side by 2, and I get y is equal to 12.5. Okay, we're going to let you work on this one on your own. Good luck. Okay, so these two triangles are equal. So, like I said, it always helps to mark the diagram up. So L matches up with Q, and M matches up with R, and N matches up with S. Okay. And segment LM is congruent to segment QR, right? LM and QR match up. All right, so let's set up our equations. So QR is 3x minus 9, and LM is equal to 2x plus 11. Okay. So now we just do some algebra, right? Add 9 to each side. 3x is equal to 2x plus 20. Subtract 2x from each side. x is equal to 20. Okay. Since both of these angles here are, so M has 2 tick marks and so does R, those two angles are congruent, right? So we're going to make those equal. So 2y minus 40 equals y plus 10. I'm going to add 40 to each side. So 2y equals y plus 50. Subtract y from each side, and y is equal to 50. Okay, here's an example of third angle theorem in practice. So you guys go ahead and solve this one. Okay, so third angle theorem, we learned that we have a right angle here that's congruent to this right angle. We have this angle is congruent to this one. Therefore, these two angles here are also congruent. So 2x would equal 80. Divide each side by 2. X equals 40. All right, go ahead and do this one. All right, again, we have third angle theorem. Now, the thing that we have to look at, though, is this third angle is equal to what? Well, because we have 65 and 41, right? This would also be 65, right? And not 41, this is 51. So we could do this a couple of ways, but I think the easiest thing to do is just take this and make them add up. 4x plus 65 plus 51 all adds up to 180. So 4x, 65 plus 51 is 116 equals 180. I'm going to go ahead and subtract 116, from each side. Right? And 180 minus 116 comes out to 64. So 4x is equal to 64. Divide each side by 4. And x is equal to 16. What? The heck? Oh my.